Okay, guys, we were just finishing up finding out that sometimes when we solve a system of two equations, we get no solution. What this means graphically is that the lines were parallel. Okay, we have two lines that are never going to intersect. Okay, so there's no solution. And you'll see that because if you check, they do actually have the same slope. If I would have put this one in slope-intercept form, I might have seen that. This one, however, has infinitely many solutions. Now, before college algebra, we would just stop there and say, hey, there's a lot of solutions, okay? Infinitely many. A more sophisticated way to answer that is there are a lot of solutions, and what happens is these are the exact same line, okay? Let's say we divide by 2. This line is actually y equals 1/2 x plus 3/2, right? And if I would solve this one for y, I would get the same thing. Y equals 1/2 x plus 3/2. So what we say is there are infinitely many solutions, and the answers are all ordered pairs x, y, such that y equals 1/2 x plus 3/2. Okay, let's write that better, please. Okay, here's how we write that. All ordered pairs x, y, such that the y coordinate equals 1/2 the x coordinate plus 3/2. Okay, in other words, what we're saying is all the answers are any xy on this line because they both ended up being that same line. Okay, to say there's infinitely many solutions, like, okay, what are they? Whether it could just any old numbers, that's how we stop in high school algebra, but in college algebra, we say there's infinitely many solutions, and those solutions happen to be all the xy points on this line. Okay? All right, so let's use this for some word problems here, some real life applications. At the book exchange, all paperbacks sell for one price, and all hardback books sell for a different price. Tanya got 6 paperbacks and 3 hardbacks. She spent $8.25. Greta got 4 paperbacks and 5 hardbacks and spent $9.25. Todd's trying to figure out what his bill's going to be because he's getting 7 paperbacks and 9 hardbacks. But the girls forget what each book sold for. So they're trying to figure out, well, wait, how much was actually one paperback book? How much was one hardback book? They're like, I don't know. Here's what I got, and my total was $8.25. That's all it says. Blah, blah, blah. Okay? So what we want to do is set up a system of equations here. Okay? Tanya got 6 paperback books. Let's let X be the paperback. She got 3 hardback books. We'll let Y be the hardback books. She spent $8.25. Okay, so 6 times however much a paperback book costs plus 3 times however much a hardback book costs should equal $8.25. Greta ended up getting 4 paperbacks and 5 hardbacks, and she spent $9.25. So all we have to do is solve this system, and we'll be able to tell you what a paperback book was and what a hardback book was. Okay, so go ahead and try that one. I need these to disappear, one of these to disappear, right? So I think I'm going to get rid of the y's. You get rid of whatever you want. I'm going to get rid of y, so I am going to multiply the top by -5, and I'm going to multiply the bottom by +3, because that will make this -15y and +15y. So I have -30x minus 15y equals whatever 5 times 8.25 is, 41.25. We'll multiply 3 through. We get 12x plus 15y equals 3 times 9.25, which is 27.75. That's a negative, isn't it? Yeah, -5 times everything. Okay, let's add those together. We'll get negative 18x equals negative 4125 plus, what was that, 2775? That's negative 1350. So if I divide by negative 18, I get x to be 75 cents. So a paperback book must have been 75 cents. To figure out what a hardback book is, I'll pick either one of these equations. I'll just do this bottom one a while, okay? And I'll plug the 75 cents in and solve that for y. Okay, so 4 times 75 cents is 3. So I'll subtract 3, subtract 3. I get 5y equals 625. 625 divided by 5. Y equals $1.25 for the hardback books. And this is 75 cents for paperback. So we'll be able to tell him how much his bill is going to be. It's going to be 7 times 75 cents plus 9 times $1.25. 7 times 75 cents plus 9 times $1.25. He better have $16.50. Ready to go. Okay, so see how, just solving a system of equations, we can, we can get to information that we might not otherwise not been able to do. Isabella paid for her $1.75 lunch with 87 coins. They were a mixture of nickels and pennies. How many of each were there? Well, I know there's 87 coins. Let's let N be nickels, P be pennies. Okay, so my nickels plus my pennies add up to 87. Okay, I also know that a nickel's worth 5 cents. A penny's worth 1 cent. And if I take 5 cents times the number of nickels plus 1 cent times the number of pennies, I should have $1.75. Now I might, sometimes when I just have one, a variable without a number in front of it, I will solve for that and use substitution. Like I know the number of nickels is 87 minus P, right? I might subtract P from each side and stick 87 minus P in for N, okay? So we have 0.05 times 87 minus P plus 0.01 P equals 175. So 0.05 times 87 will distribute through here. 435 minus 0.05 P plus 0.01 P equals 175. I'll subtract 435 from my 175, and I'll add these together, giving me negative 0.04 P, right? Negative 0.05 plus 0.01, okay, is where I got that. Just combine my P's. Minus, I subtracted 435 from 175 and got negative 2.6. So we'll divide by negative 0.04. The number of pennies, negative 2.6 divided by negative 0.04, the number of pennies was 65. And then I'll take 87 minus that 65 to get the number of nickels to be 22. So 22 nickels and 65 pennies. And then I would just probably double check that that is $1.75, right? And it is. Okay? Gives you another idea. So guys, this homework is on, I have this on Schoology, the page number that I want you to do. Sorry that it's so jumbled, but I'm trying to make sure that you do a good number of these solving systems of two equations to give you a good variety. I want you doing some word problems. I want you to solve sums that, you know, are infinitely many solutions, some that have no solutions, some that you should use substitution, some that you should use elimination by addition, just to give you a nice variety, but not have you do quite so many. Okay, so if you'll do 7 to 13 odd, that's 4 problems. 17 to 21 odds, that's 3 problems. 25 to 29 odd, that's 3 problems. 41 to 45 odd is 3 problems. So 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 20. So this is 21 problems, but yet we go from 7 to 72. Like I'm trying to give you a nice variety. Please try these 21 problems, okay? Make sure you really get this homework down, okay? All right, guys. I'll talk with you later. Hope to see you soon. Bye.